The air breather is used to allow pressure caused by blowback gases such as air, unburned fuel and exhaust to escape the crankcase. This improves the general performance and longevity of the engine. Blowback gases are generated when a small but continual amount of gas leaks from the combustion chamber to the crankcase via slight gaps at the piston rings and valve stems. The exhaust fumes can cause contaminants to enter the engine oil, and if pressure is allowed to increase enough, several components such as the cylinder head could be blown off, destroying your engine. The breather controls the pressure in the crankcase using a one-way reed valve, and this valve allows the pressure to be relieved whilst not letting gases back in.
The outer casing of the breather is ferromagnetic, meaning it is likely made from an iron-aluminium compound. Durability and resistance to corrosion are two important properties in ensuring the casing isn't damaged or corroded due to the high pressure and high temperature air and oil particles that are being directed through the breather. As the main function of this component is to repeatedly allow through the passage of air in one direction, the one-way valve, or variable orifice, must have the material property of elasticity to ensure it is not deformed after one use. Other general properties to ensure the workings of the air breather include being lightweight to not induce fatigue loading on other components, and to have low thermal expansion when exposed to these hot airflows.
You can tell this part was likely produced using metalworking as it has undergone shearing to cut out the holes seen in the part. This, along with the part being made from a thin metal sheet, indicates that the part has gone through sheet metal forming of some form in its production, as this is the most cost-effective method to produce this type of part. As this part is being mass-produced for every engine, it is important that the price per unit produced is as low as possible. Pressing and shearing the part in its production are the most efficient ways to ensure this, and are evidence that the part was produced using metalworking.
Firstly, sheet metal of the desired thickness is taken and placed between two die halves that will press together and force the metal to plastically deform into the dies. The pressing process is done cold, i.e. room temperature, and this process must occur first as it will plastically deform a large part of the sheet which would deform any holes that have been pierced beforehand. The pressed sheet metal would be placed under a pressure plate to constrain the sheet during piercing. Then a series of punches would pierce the sheet with high enough force to make the sheet shear in the determined regions by using a compound die. The next process would be to blank the breather out of the sheet. This would be done at this stage to minimize the difficulty in pressing and punching the breather as a singular piece rather than as part of a full sheet. Blanking will be done using a punch in a similar action to piercing. However, in this case, the workpiece is removed from the sheet metal.